2. Let's put what we have just learned into a chemical reaction. Let's review the chemical equation that we have learned in the previous chapter. In a chemical reaction, we can see products and reactants, 反应物和生成物。Reactants are on the left-hand side of the equation, and the product is on the right-hand side. This is the combustion of carbon, 碳的燃烧反应. Carbon reacting with an oxygen molecule, which is an O2 molecule, to form a molecule of carbon dioxide, to form a molecule of CO2. In the previous chapter, we have learned how to balance the chemical equation so that on the left-hand side and on the right-hand side, you have the same number of atoms. On the left, we have 1 carbon and 2 oxygens. Same on the right, we have 1 carbon and 2 oxygens. So, this is what this equation tells you. 1 carbon atom reacts with 1 oxygen molecule to give 1 carbon dioxide molecule. The ratio is 1 to 1 to 1. 它的比例是1比1比1。它的比例就是前面的系数比。If we multiply this equation by 1 mole, then this equation should still be true. For example, if I say, instead of having 1 carbon atom, I have this many carbon atoms, reacting with this many oxygen molecules. And that will give me 1 mole of CO2 gas molecules. Yes? Take a few seconds to think about the conversion. And just now we have studied how to get mole to mass. Mass is equal to molar mass multiplied by the number of moles. If you're looking at 1 mole, then 1 mole of carbon is 12 grams per mole, because the atomic mass of carbon is 12. If you want to calculate the molecular mass of oxygen, each oxygen is 16. The molecular mass should be 32. That means the molar mass of oxygen is 32 grams per mole. Similarly, you can also work out the molar mass of carbon dioxide. It should be 12 plus 16 times 2, which is equal to 44 grams per mole. And we can immediately know the mass of 1 mole of carbon, mass of 1 mole of oxygen, and mass of 1 mole of carbon dioxide. And the masses are 12 grams, 32 grams, and 44 grams, respectively. Okay, so how can we put that into all sorts of questions? Here are the standardized steps. When we do calculations, I strongly suggest you to convert everything into moles, and then you can use your molar ratio to determine the unknowns. In this example, we need to produce NH3 from N2 reacting with excess H2. 他问你NH3 的质量是多少？当 42.03 克的氮气与过量的氢气反应。Okay, so let's firstly write down the balanced equation, identifying your reactants and the products. We have only one product, NH3, and your reactants on the left-hand side are N2 and H2, producing NH3. But this equation is not balanced, so you need to balance the equation. I would just suggest you to balance nitrogen first and hydrogen next. Pause the video to balance the chemical equation. So your answer should be 2 to balance the nitrogen, so you have 2 and 2 on either side, and 3 in front of H2, so you have 6 hydrogens on each side of the equation. And then you can list down the knowns and unknowns. What do you know? I know the mass of nitrogen, so I know this baby M, which is 42.03 grams. What I don't know the mass of NH3 produced, and I don't know the mass of hydrogen involved, and you want to find out the mass of NH3 produced. And there are other things that you know as well. If you want to go to a periodic table, you can find out the molar mass, big M. For nitrogen, the atomic mass is 14, hydrogen is 1. So the molar mass of the nitrogen molecule should be 28 grams per mole. And the molar mass of NH3 should be 17 gram per mole. That's 14 plus 1 times 3. So once I have listed my knowns and unknowns, you can convert into moles. Remember the key formula. I'm gonna put the key formula into a box. Our key formula is mass is equal to molar mass times the number of moles. The number of moles is equal to baby M divided by big M. To convert into moles, we can find out the number of moles of the N2 by using baby M divided by big M, which is equal to 42.03 divided by 28. And this is roughly 1.5 moles. And then, lastly, you can use the molar ratio to determine the unknowns. So what does this stoichiometry ratio tell you? This tells you the number of moles or the number of molecules of nitrogen to the number of molecules of ammonia is 1 to 2. For every molecule of nitrogen involved, 2 molecules of ammonia is produced. So, if the number of moles of nitrogen molecule is already known, which is 1.5 moles, you're just looking for an unknown, the number of moles of NH3. So X should be equal to 3 moles. Okay, if you're not sure about the math, then you can put it down as a ratio. Again, I'm going to put this into a box if you need additional mathematics support. So 1 over 2 is now equal to 1.5 divided by x, and you're looking for x. So you can use the crossing method. X is equal to 1 times x is equal to 2 times 1.5, and that's equal to 3. Right. Lastly, you want to convert it into mass. So according to this step, I've worked out the number of moles of NH3. This is 1.5 moles, and this is 3 moles. You just need to work backwards to find out the mass. So, using this key formula, baby m is equal to big M times small m. Big M is 17 grams per mole, small n is 3 moles. So lastly, convert into mass. The mass of NH3 bracket is equal to 17 times 3, and that's equal to 51 grams. Now, you can move on to the section in-class practice. Once you have done this, you can move on to your homework. Your homework is workbook 6.1, 6.2, and 6.3.